In calculus, we often want to know how one variable changes in relation to another. For example, a business person might need to know how revenue will change if production changes. A doctor needs to know how the concentration of a drug will change in a patient's bloodstream over time. An employer needs to know how production will change with training. There are two ways to look at these changes. One is called the average rate of change, and the other is instantaneous rate of change. We are first going to look at average rate of change. Average rate of change is something that you do all the time without even thinking about it. You say that you drove 150 miles in 3 hours, so you drove 50 miles each hour. Does that mean you drove exactly 50 miles per hour the entire time? No. It just means that the average speed that you went was 50 miles per hour. On example 1, we are told a driver makes a trip from Cleveland to Columbus in 3 hours, and this is a distance of 168 miles. The table shows how far the driver has driven from Cleveland at various times. And so you are told, for example, in the first time at time 0, you haven't driven any distance. Well, that makes sense. At time 1/2, 0.5, you have driven 22 miles. At time 1, you have driven 52 miles. If you think about this, how long you drive causes how far you go. So the cause in a problem like these is always the x coordinate or the x variable. So time will be x. And then how far we drove will be y. When you want to find the average rate of change from 1 hour to 2 hours, think about what we say. We say that we drove so many miles per hour. So when we want to find the average, we want to put the miles on top over hours. So when we do our average, we want our hours to be on the bottom. I'm going to do 2 minus 1 because that'll give me a positive answer. Now for the numerator, you have to put the distance you went at 2 hours, which was 118 miles, minus the distance you went at 1 hour, which was 52 miles. If we do the subtraction in the numerator and the denominator, we get 66 in the numerator over 1 in the denominator, which means that our average was 66 miles per hour. Does that mean the entire time we drove that fast? No, it's just our average. For example B, we want to find the average from 2.5 to 3 hours. So our average rate of change here, at 3 hours we had driven 168 miles, minus at 2.5 hours we had driven 148 miles, over the 168 went with 3 minus 2.5. Doing that arithmetic, we're going to get 20 over 0.5, and if you take 20 divided by 0.5, you get 40. So our average is 40 miles per hour. If you think about what we did on both of those problems, we took a y minus a y over an x minus an x. Does that sound familiar? It should. It's the same idea as the slope formula. This leads us to our formula for rate of change. Our average rate of change formula is f of b minus f of a over b minus a. Remember what f of b means. If I tell you to find f of 3, that means put 3 into the function for x and find out what the y equals. So this is just another way of writing y minus y over x minus x. On example 2, we are given that f of x is x squared plus 4x plus 5, and we are asked to find the average rate of change over the interval from 1.9 to 2. When you look at this and you see an interval, these values in the interval are x values. So this is x value A, this is x value B. If you think about what our average rate of change formula says to do, it says to find f of B and f of A before you can actually do the subtraction. So the first thing that we are going to have to do is find what we get when we put 2 into our function. We would have 2 squared plus 4 times 2 plus 5. So we get 4 plus 8 plus 5, which gives us a total of 17. For f of 1.9, we are going to do 1.9 that we are squaring plus 4 times 1.9 plus 5. And in doing that on your calculator, you should get 16.21. So now we're ready to actually find the average. For the average, we're going to take the answer. This is f of b right here. And this is f of a. So we're going to take the answers minus each other. So we're going to take 17 minus 16.21 over the x's, 2 minus 1.9. In doing that, you will get 0.79 over 0.1, which gives us an answer of 7.9 as our average rate of change.